Hi, my name is Irish Selkumar, and here I'll just take you through my second assignment of my deep learning assignment. So, the first thing the point of this video is just that you wouldn't have to download anything and you wouldn't have to, set any folder paths or things like that. So the first thing is to get the data set. So, I use Safari, and for a cat class, it types into the Google Images search bar. It types in cat, domesticated cat, house cat, and then it's just going to try to get 400 images of each. From my experience, it can't really get all the images. I think I've got about 800 in total for this class because there will pretty much always be download issues and things like that. So it saves it to this location, and if you want to get some more images, you wouldn't have to start from zero. And it does the same thing for the cow class. And I will just run it here so you can see. I wouldn't run the whole thing because it takes about half an hour. It should pop up. There we go. It's doing that by itself. I'm not in control of my browser. As you can see, my cursor is at the very top of the screen, and it's just going to keep downloading those images. So it clicks on those images and it downloads them. Then so I'll stop that because that'll take a while to do. And I also have the images already here. As you can see, if I click on one, it's nice happy cat. And then here it checks if they're corrupted, and it deletes corrupted images. So if you want to have the numbers, like in the correct chronological order, you just reset the image numbers. So that's that. I guess if you go into the next part, that's to see our neural network being trained. So I set up that exception pre-trained model. I have, I guess, two other ones. No, I have one other one here, which is VGG16. I guess if you just wanted to add more, you just have an elif loop if you want. So and with the batch size of 32, I found that to be the best. Bigger and smaller batch sizes didn't have as good of a performance. So it sets your training data, and then it adds our head layers. I guess this is the layers after the base layer of the base models. Sorry, after the last layer of the base model. Sorry. So I added batch normalization, a global average pooling, a dense layer with 512 nodes, a batch normalization layer again. I think this is actually incorrect. I think in my report I had better accuracy if I took this out. I'm not too sure. You'll have to check in the report anyways, because I know, and then there's a sigmoid with 1 at the end, but I was only able to test about 10 because it took way too long to train. I tried using Google Colab at the start, but it was training slower on Google Colab for some reason. I couldn't really get it to work. So I just had to train it on my local machine. And here it just trains it, and you save it, so you wouldn't have to train it again. Now, if I run that, I'm not going to run it the whole way because it takes a while. So here it prints it out, and then you would just run through the epochs. Speaking of epochs, I guess 25 was the best. Any more than 25, I got overfitting, and any less than 25, I got, underfitting. And that was from very limited testing, so that's okay. Okay, so next we would test the model. So we tested on an unseen data set. So we load the model then. Yeah, we load the model and then we test it. So if I run that, set this to 2. So if we run that, there was about 100 images for each class of the unseen dataset. As you can see, it's just going to print out the results. It's almost done. So, and in the end, it will have an accuracy of 89.24. I think that seemed a bit, abnormally high. I don't know if I'm doing something wrong or if that's correct, but it was still good. And then the third one, so this is the big part of the assignment, which is to get weak class detectors and then visualize the output of those neurons. So once again, it's a 199 by 199.3. Actually, that's the correct shape. It's 150 by 150 by 3. Sorry. And then, so basically, you add a global average pooling layer, and then you add a dense layer with a softmax activation, and then you compile the model using that Haddam optimizer, and then you would use binary cross entropy as your loss function, and and then you get your weak class detectors. The code's all pretty well commented up here, so it'll be easy enough to follow, I hope. And then I would print it. So I'll clear that and I'll run this. I'm not going to run. Actually, I will run it fully because the first time you would run it, it takes a while because it's not saved to disk, and then it would be saved to disk for those subsequent runs. So that's good. So actually, so here is the output of our neurons. So this is the neuron 182. It got some activations around here. Yes, a little bit around there. Now, I couldn't get the object localization to work completely. I think you would have to combine the outputs of multiple neurons for that. But as you can see, it's some activation here. I guess I was able to pick out the head of the cow. The rest, not so much. Next one, 390. I guess picked up some grass, I think. Grass again. Some bits over there. Yeah, so you get the picture, I guess. And yeah, this one's actually quite good. So that's it. So that was it. Thanks for watching, I guess, and apologies if you hear a lot of breathing noises because I have a fever at the moment, so I'm not feeling too well, but that's okay. Yeah. So thanks for watching.